This is the first topic of the chapter, Properties of Acids and Alkalis. Acid and alkali are the substances that dissolve in water to form solutions, in order to exhibit their acid and alkali properties. In other words, all acid and alkali must be soluble in water. Now, let's our discussion focus on the acid first. Acid is a chemical compound that will be ionized to hydrogen ions, H+, when dissolved in water. With the attendance of positive hydrogen ion in the water, the solution becomes acidic. This is the mechanism of how an acid exhibit its acidic property. When an acid, for example, acid H, A, dissolve in water, this acid H, A, will be ionized to be positive hydrogen ion and negative A ion. The hydrogen ion in the solution is the key item to make the solution become acidic. Let's use sulfuric acid, H2SO4 as an example for the explanation. When sulfuric acid dissolve in water, sulfuric acid being ionized to be positive hydrogen ion and negative sulfate ion. The positive hydrogen H+ ion in the solution make the solution become acidic. Now, we use hydrochloric acid, the HCl acid, as an example for the explanation. When hydrochloric acid dissolve in water, hydrochloric acid being ionized to be positive hydrogen ion and negative chloride ion. The positive hydrogen ion in the solution make the solution become acidic. The following are the 5 general properties of acid. The first property of acid is, acid has pH value less than 7. At pH scale is the scale range, from 0 to 14. It is used to measure how acidic or alkaline a substance is. pH value less than 7 is acidic. pH value equal to 7 is neutral, and pH value more than 7 is alkaline. The second property of acid is, acid will change the blue litmus paper to be red, and remains the red litmus paper in red color. At which, litmus paper is an indicator, used to indicate the acidity or alkalinity of a substance. The third property of acid is, acid tastes sour. The fourth property of acid is corrosive. It will damage or destroy other substances when it comes into contact by means of a chemical reaction. The strong acid is usually attached with the pictogram for corrosive. The lower the pH value of the acid, the higher the corrosiveness. Acid reacts with metals such as magnesium, aluminium, zinc, and iron to release hydrogen gas. There are 2 types of acid. The first is organic acid. The second type of acid is inorganic acid. Organic acid is the acid that consists of carbon element and can be found in plants and animal. For example, acetic acid. We may find the acetic acid from vinegar. Lactic acid. We may find lactic acid in sour milk or yogurt. Citric acid. We may find citric acid from orange and lime. Ascorbic acid. This is vitamin C. Carbonic acid. Carbonic acid, when carbon dioxide is dissolved into water. Carbonic acid then, further dissolve into positive hydrogen ion. Carbonic acid is used to make soft drink. When you open the can, some of the carbon dioxide molecules break out of their carbonic chain gang and bubble up to freedom. This causes the fizz. Inorganic acid is the acid that prepared from mineral salt. Mineral salt is the compound of the inorganic element. Inorganic acid is also known as mineral acid. For example, hydrochloric acid. We may find hydrochloric acid from the gastric juice. Nitric acid. Nitric acid is widely used in the manufacturing of explosives and fertilizers. Sulfuric acid. Sulfuric acid is used in car batteries. Phosphate acid. Phosphate acid is used to produce fertilizer, and for food flavoring. The following are the examples of organic acid. Acetic acid, it existed in vinegar. Tartaric acid, it existed in grape. Citric acid, it existed in lime, and orange. Malic acid, it existed green apple. Lactic acid, it existed in sour milk, and yogurt. Formic acid, it existed in bees, and ants. Tannic acid, it existed in tea. Carbonic acid, it existed in carbonated drinks. The following are the examples of inorganic acid. Hydrochloric acid, it existed in gastric juice. Sulfuric acid, it is used in car batteries. Nitric acid, it is used in the manufacturing of explosives and fertilizers. Now, we talk about alkali. Alkali is a chemical compound that will produce hydroxide ions when it dissolved in water. Alkali is formed when oxide and metal hydroxide dissolves in water, at which hydroxide ions, OH, is produced. For the above mentioned, we may conclude that alkali can be formed from two scenarios. The first is when the metal oxide dissolve in water. The second is when the metal hydroxide dissolve in water. We first see the mechanism of how metal oxide dissolves in water can produce the alkali. Metal oxide dissolves in water to form the metal hydroxide. Metal hydroxide further dissolve in water to form negative hydroxide ion and positive metal. With the attendance of negative hydroxide ion, the solution exhibits Al property. Let's use potassium oxide as an example for the explanation. Potassium oxide dissolves in water to form potassium hydroxide. Potassium hydroxide dissolves into negative hydroxide ion and positive potassium ion. The hydroxide ion in the solution enable the solution to exhibit alkaline properties. Second example is sodium oxide. Sodium oxide dissolves in water to form sodium hydroxide. Sodium hydroxide will further dissolves into negative hydroxide ion and positive sodium ion. The hydroxide ion in the solution enable the solution to exhibit alkaline properties. Third example is calcium oxide. Calcium oxide dissolves in water to form calcium hydroxide. Calcium hydroxide dissolves into negative hydroxide and positive calcium ion. The hydroxide ion in the solution enable the solution to exhibit alkaline properties. This is the mechanism of how metal hydroxide dissolves in water can produce the alkali. Metal hydroxide dissolves in water, and then metal hydroxide ionized into negative hydroxide ion and positive metal ion. With the attendance of negative hydroxide ion, the solution exhibits alkaline properties. Let's take the potassium hydroxide as an example to explain the mechanism. Potassium hydroxide dissolves into water, and then, being ionized to be negative hydroxide ion and positive potassium ion. The hydroxide ion in the solution enable the solution to exhibit alkaline properties. Now, we use sodium oxide as an example to explain the mechanism. Potassium hydroxide dissolves into water, and then, being ionized to be negative hydroxide ion and positive potassium ion. The hydroxide ion in the solution enable the solution to exhibit alkaline properties. Now, we use sodium hydroxide as an example to explain the mechanism. Potassium hydroxide dissolves into water, and then, being ionized to be negative hydroxide ion and positive potassium ion. The hydroxide ion in the solution enable the solution to exhibit alkaline properties. The following are the 6 general properties of alkali. The first property is, alkali has pH value more than 7. At which, pH scale is the scale range from 0 to 4. It is used to measure how acidic or alkaline a substance is. pH value less than 7 is acidic. pH value equal to 7 is neutral, and pH value more than 7 is alkaline. The second property is, alkali will change the red litmus paper to be blue, and remains the blue litmus paper in blue color. At which, litmus paper is an indicator, used to indicate the acidity or alkalinity of a substance. The third property is, alkali is tastes bitter. The fourth property is, alkali is corrosive. It will damage or destroy other substances with which it comes into contact by means of a chemical reaction. The strong alkali is usually attached with the pictogram for corrosive chemicals. The higher the pH value of the alkali, the higher the thickness. The fifth property is, alkali does not react with metals to release hydrogen gas. The sixth property is, alkali reacts with ammonium salts to produce salt, water, and ammonia gas when heated.